Alright, hello everybody. Once again, you should hopefully be in your seat and have something down for your do now. If you do not, though, go ahead, take 4 minutes silent and solo, work on this do now. Again, 4 minutes silent and solo, please begin. You can go ahead and pause here. Alright, so now that we've gone through that do now, we're going to go over questions 1 and 2. And so question 1 says to write an equation of a line with a slope of 1/2 that passes through the point -6, -4. Now this should be super fast for us. It should be really familiar. We should absolutely have this down pat. We should see boom slope, boom point. We know that we're going to be using point slope form. So I know that instantly here, I'm going to have that y minus -4. I'm going to make sure and take the time to actually write these out because these are both negative values in that point. Then I'm going to have my slope, which is 1/2, and then x minus a -6. So once I've written this out like this, I'm just going to go through, take out my double negatives, make sure I'm changing those to positive. So I'm really going to have that y plus 4 is equal to 1/2 x plus 6. Alright, number 2, write a possible equation of a line that is perpendicular to y equals -3x plus 2. Alright, so we saw how to do this yesterday. In some classes, you've had some extra practice with this in your float, but we see that our M1 here is going to be a lovely -3. And so remember that if we have two lines that are perpendicular, we know that M2 is going to be equal to the opposite reciprocal. Let's erase that. I'm getting ahead of myself. The opposite reciprocal of our first slope. So M2 is going to actually equal -1/M1. So what that's going to look like is that M2 is going to be -1/3. Now this negative sign here and this negative sign here, they're going to cancel each other out. So I know that M2 is going to be 1/3. It's going to be a positive 1/3. And now, it doesn't give us any other information other than just write a possible equation. And so I know that if I'm only writing a possible equation, I can take this and write this in any other way that I need. And so I'm just going to simply have that y is equal to 1/3x minus 1. Again, remember that you can pretty much have anything here, especially when we're looking at perpendicular lines. You can even have the same y-intercept because this slope guarantees that these lines are going to be different. So we don't have to worry about accidentally writing the same exact line. Alright, if you had made it to number 3, that's awesome. Number 3, again, should kind of be old hat. Very similar to number 1, only you do have to actually calculate the slope. But then, it's the same exact process. So, today you will have homework. It is the last page in your packet. So let's make sure we tear that page off and we put it somewhere safe. Take 30 seconds. Make sure that your homework is safe with you in your bag. Go. Alright, we should have like 15 more seconds here. Alright, 5 more seconds. All homework should be away, not on your desk. And okay. So, now that that is away in a safe place, go ahead and take out your notebooks. Go ahead and pause the video, and once everybody has their notebooks out, we will continue. Alright. So, today, we're not worried about example 2, just like yesterday. We are looking at example 1, and example 1 says that line L is represented by the equation y equals 1/2 x minus 3. Line T is perpendicular to line L and passes through the point -1/4. We need to determine the equation of line T. So, go ahead, take about 45 seconds, make sure today's date is at the top of your page, and write down example 1. You can go ahead and pause the video, and we will move forward once everybody has this. Alright, so again, we know that line L is this lovely y is equal to to 1/2 x minus 3. So I know that I'm going to kind of pick this apart. I know that I'm dealing with a perpendicular line, so I'm really looking at slope here. And so I know that m of line L is equal to 1/2. So that means that the slope of line T, again, is going to be that opposite reciprocal of line L in this case. So what that's really going to look like, I know that the reciprocal of 1/2 is going to be 2, right? Because with fractions, I'm actually just flipping this. So I'm going to have 2 over 1, which is equal to 2. And then I'm going to have this negative sign here. So because of that, I know that the slope of line T is going to be equal to a -2. And then once I have my slope, I do have to kind of go back and look because they do give us another piece of information, right? They tell us that, hey, this is going through the point -1, 4. So I need to use this new slope that I just found here with this lovely piece of information to create the full equation of the line. Now again, it doesn't tell me what form it needs to be in, so I'm going to see that the information I have, and I should hopefully in my head immediately recognize, hey, once again, it's going to be point slope form. So I know that y minus 4 is going to be equal to -2 times x plus 1. And there we have it. That's the equation of our lovely line. And again, remember, this we changed to a positive because this right here is a negative. Just like we did up top, I'm just simplifying it into one step. So make sure we have this, and then we're actually going to do a quick stamp below this. So go ahead and pause here if you need to. All right, so down below this, we're going to do a really quick stamp. Because it's something that we've done a few times, we just might not have been aware that we're actually doing it. And what this is really going to involve is that we need to remember what the form for a standard equation is, right? And so when I say that, it's really the standard form of a line. And we know that that is ax plus by equal to c. Yes, and then we do have our lovely caveat as well that, hey, when we have this, we know that a, b, and c all have to be integers, right? We know that a, b, and c all have to be integers, but this is the standard form of an equation of a line. So if I'm looking at my standard form, what I really want to see, especially now that we're dealing with parallel and perpendicular lines, is there a faster way to find slope rather than having to always solve for slope intercept and then kind of taking it from there? And so we're actually just going to work with this in its general form. And by that, what I mean is we're going to subtract ax from both sides here. And so I'm going to have that by is equal to negative ax plus c. And then from here, I'm going to multiply both sides by 1 over b. And if you're looking at this and going, hey, this process seems familiar, it's because you're right. This is the same process that we've been doing. Anytime we take standard form and move it into slope-intercept form, I'm just keeping the original variables in here. And so once I do that, this 1 over b is going to cancel with this b, just as though these were numbers. And I'm going to be left with that y is equal, and I'm actually going to take this fraction, and just like I would, and as we have previously, I got to distribute this in. So I'm going to, y is equal to negative a over bx plus c over b. Now by rewriting this actually tells us two really important pieces of information that's just going to be way faster to use this than to always constantly have to simplify and solve and change standard to slope-intercept to get meaningful data. What this is really saying is that I know for a fact that this is definitely still in y equals mx plus b form. And so if I look at what I have in these spots, I know that after looking at something that's in standard form, the slope will always be negative a over b, and my y-intercept, or my b value, is always going to be c over b. And these are two things we really want to highlight and star. Whatever you have to do, underline them, box them, anything that you do so that you can see this and know that, like, hey, like, this is an important thing because this is going to allow us to save a lot of time and skip all of this mess and just go, oh, okay, I have this ax plus by equals c. Well, I know that my slope is negative a over b, and that my b value, or my y-intercept, is going to involve c divided by b. So again, make sure we have this down, because these are the general forms of our slope when looking at something in standard form. Go ahead and pause the video here if you need to. Make sure everything we have on this right here is down in your notebooks, and feel free to ask questions if you have them. Go ahead and pause. All right, so with that, we're going to turn our attention back to our packets. We're going to go to problem set A. In problem set A, we're actually just going to start with number 1 here. I want us to just work on number 1. It's going to look very similar to exactly what we did in our notes. So go ahead, work on number 1 for problem set A. You're going to have 2 minutes, silent and solo. You may begin. Go ahead and pause the video here. All right, so before we move on, we just want to quickly go over number 1 to make sure that we are all on the same page, right? And so we're being told, hey, if h of x is equal to negative 2 over 3x minus 1, and g of x is perpendicular to h of x, and goes to the point negative 4, 3, find the equation of g of x. Now this is exactly like we did in our notes. They're just called different things, right? I just have a little bit more specific functions where instead of it's line L or line M, I am told that it's g of x and h of x. So, I know that we're going to be perpendicular. So I'm going to take this slope here. I have negative 2 over 3, and that's the slope of line H. So I know that if that's the slope of line H, the slope of line G is going to be its opposite reciprocal. So I'm going to flip my fraction and change my sign. So it's going to become positive, and it's going to be 3 over 2. And so once I have my slope and a point. Again, same thing as above, I have point slope form. So I'm going to go ahead here. Remember that when we have g of x, we're simply going to put that in place of y. When we have stuff like g of x and h of x, what we're really saying is that we have a specific function, h or g, in terms of x. So it's a different way to describe a line, like saying y is equal to, but it's a little bit more specific. So I have that g of x minus 3 is going to be equal to 3 over 2 x plus 4. Again, notice that this is a positive because that is a negative. And that's it. That's the lovely equation of my line. I don't have to go any further. Again, we write g of x in place just like we would with y. So we have that g of x minus 3 is going to be equal to 3 over 2 times the quantity of x plus 4. All right. Hopefully you're able to follow that down. If not, or hopefully you already had that down. If not, make sure you stamp this final equation here, or even the slope if you forgot to change the sign or didn't flip it quite right. But then we're going to move on to questions 2, 3, and 4. For these 3 questions, you're going to be able to work with the person next to you. Again, for this partner work, we should not be leaving our seats. Work with the person next to you for 2, 3, and 4. You're going to have 6 minutes. Go ahead and start, and you can pause the video here. Alright, so hopefully you and your partner got through all 3 of these questions. We're going to go over number 2. Number 2 says that line 1 is represented by the equation y is equal to 4x minus 5. And line 2 is parallel to line 1 and passes through the point 2, negative 3. Write the equation of line 2. Alright. So first thing I know, line 2 is parallel to line 1. Awesome. And I know that it passes through this point. So, first thing I got to look at is the slope of line 1. Slope of line 1 is 4, right? Because this is lovely value here. And I remember that when I have something that's parallel, I know that slope 1 is going to be the same exact thing. It's going to be equal to slope 2, which means that the slope of line 2 is also 4. Fantastic. Makes this super easy, because then I'm just going to take my point and my slope and go ahead and write this out. Now, we are not given exactly what variables we have to use, so we can go ahead and say that y plus 3, again, always keep note of our negatives and what it's going to do to our equation. So y plus 3 is equal to 4 times x minus 2. And that's as far as I have to take it. That's our lovely parallel equation. If you have any questions on 3 or 4, go ahead and raise your hand. Whoever is filling in with me will have the key, and they'll be able to kind of give you that quick hit of exactly which one it is. But we're only worried about going over 1 and 2 right now. Make sure you have this down. You can go ahead and pause the video here, and once everyone has it, we will move on. Alright, so we're moving down to problem set B. Hopefully you're noticing that these are really quick. These are pretty fast. It's something that we should definitely have down by now. For some of us, this is day 3 with parallel and perpendicular lines. For some of us, it's day 2. But hopefully we're kind of seeing and getting the gist of these and really being able to move through these. So problem set B has some more graphical examples. You're going to work on questions 1 and 2. Again, you're going to work on questions 1 and 2, silent and solo. Take 5 minutes to go through these 2 questions. Begin. You can pause the video here. Alright, so bringing it back. Question 1 says, which of the following represents the equation of a line parallel to the line graphed below? So this is our line, and we want to find one that's parallel. So there's some interesting or useful information that we're going to have to pull from this. First thing, and most important thing, is its slope, right? Because when we're looking at parallel and perpendicular lines, that's really what we want to know. I know we just wrote it, but again, we're going to remind ourselves that parallel means, hey, slope 1 is equal to slope 2. And now I need to actually calculate my slope. And I have a few different ways of doing this, but because it's already graphed for us, I'm going to go ahead and do this graphically, because it's going to be the easiest thing for us. So I know that right here, I'm actually going to change colors just so that this sticks out a little bit better. I'm going over to the right 2. Remember that right and up are positive. So I have a positive 2 here. And I'm going down 1. Remember that down and left are negative. So if I'm looking at slope, which is rise over my run, I know that this is actually going to give me my rise is negative 1. And my run is positive 2. So from this, just by looking at this graph here, I can glean that the slope of both lines, because remember they have to be equal, the slope of both lines is going to be equal to negative 1/2. And now this is actually all I need to check and see our answers. I need to find the one that has the same slope. So option A has negative 2. Nope, not option A. Option B has negative 1. We know it's not that. Option C has a positive 1/2, so that's going to be close, but that's going to actually crisscross and form an X. And so I'm left with option D, and luckily option D, if I look at it, does in fact have a slope of negative 1/2, so I know, hey, it's option D. And again, for this, all I had to actually find was in fact the slope. All right, so moving on to number 2, we need to write an equation of the line that is perpendicular to K that passes through the point negative 1, 4. Now again, we have perpendicular, so we know that our slopes are going to be opposite reciprocals of each other. Let me make those numbers a little bit clearer. And we have this lovely point here. So I have to find my slope and then use this point to create that line. So again, I can do the same thing here that I did over there. I know that this is going to go up 1. So it's going to be a positive 1 going on there. And it goes to the right 2. So again, I have a positive 2. And so my slope of my first line is going to be my rise, which is 1, over my run, which is positive 2. So I know that my slope is 1/2. And from here, I'm going to go ahead and take the reciprocal of this. Reciprocal of 1/2 is going to be 2. And then take the opposite of that. So I'm going to have negative 2 as the slope of my second line. And so once I have that and my point, I'm good to go ahead and create this. I'm going to have that y is going to be equal, apologies. Y minus 4 is going to be equal to negative 2x plus 1. And that's as far as I have to go. This isn't asking us to graph it or anything like that. This is simply asking us to create this line. All right, and from here, if you still have more time, keep working through problem set B. Work on this again, silent and solo. See how far you can get. If you're towards the end of class, though, we are going to jump to our exit ticket. Your exit ticket is 2 questions. It's just 2 questions. Again, parallel and perpendicular lines. This will be the last day that we kind of spend fully on this topic, because tomorrow is going to be the start of a new unit, which is very exciting. But for this exit ticket, again, it's going to be silent and solo. Work till the end of class, and make sure you hand it in on your way out. I hope you all have a lovely day. You may begin on your exit ticket.